Hey guys, what's up? So today we're talking about dictionaries. And it's a pretty simple argument, but I always met so many people that don't use it, they don't know how to use it. And now I'm going to show you why they are so important and so useful. So what's actually a dictionary? Well, a dictionary is a data structure that basically is kind of like an array, but the array you have values by index. Instead, in dictionary you store values by keys. And keys usually is a string, and that means you can easily find a data you want. So for example, let's say you store in a dictionary a value, and you associate this value with translate x. So later you don't have to remember at which index you have stored your data. You can just go in the dictionary and ask, hey, I need to translate x, and the dictionary is gonna give you back the right value. So this is really useful when, for example, you're exporting data and you need to read that later, so you don't need to remember anything. And sometimes when you're exporting a huge bunch of data, you cannot remember that, and you cannot hard code your code in order to find what you need. So let's say, for example, here I have a sample scene. I want to export some mesh data about the selected object. So for example, if you select that, if I export that, I'm going to have every time some different things, like different number of geometry, different parents and whatever. Of course, I can export everything in a list, of course. But then later, I need to remember exactly which order, how I exported the data, and so on. Instead, with dictionary, it's way more flexible. If I just need to remember the basic structure, so for example, the first level is all the object, then the object holds another dictionary, which is for all my data, and then I can query the data from the dictionary. So that's what we are going to do today. Okay? So, you guys ready? Let's jump right in the script editor. So, the first thing we are gonna do is we need to get only the meshes from the selected one, and then we're going to store a couple of data like the poly count, the parent, the children, and regular stuff like position, rotation, and scale. Okay, then what we're going to do, we're going to save everything on a text file, and I'm going to show you a really simple way, a nice way to do that, and then we're gonna read it back. Okay, so let's get right to it. So let's start with a couple of imports. So that's the regular commands. Then we need Json. That's the module we use later to store on the disk. And then let's get the selection. And then we are going to loop through the object, and we are going to store only the meshes. Okay, perfect. So for every object, we're going to list the shape. Let's see, commands dot. So there is relatives command. We give s as an argument, and we need the shapes. Let's just, for simplicity, let's just get the first shape. Then we need to check if the first shape is the type we need, in this case mesh. So we're gonna use the node type on the shape 0. So if it's equal to mesh, we are going to append our value in our meshes list. It's not mesh as. So let's see how many typos we put there. Alright, so if we print meshes, so we only have psphere 1, psphere 4, 2, cube 1, psphere 3, and pcube 2. Perfect. So we see we don't have the locators. Perfect. So now that we have that, we're going to look through all the geometry. So for m in meshes, so let's get position, Okay. Hold on. First of all, let's create an empty dictionary and let's call it mesh data. Like that. So with the curly braces, it means it's a dictionary. Okay, so it's an empty one. So let's get position, rotation, and scale with the xform command. They are, maybe we can get the local data, the workspace. We can get both actually, but let's just get the work data for now. So we need so query translate workspace and translate. Then we need the rotation. I never remember what's the short name for the rotation flag, so I always spell it wrong. And then we need the scale. Let's just call this SGL. So let's see if everything is correct. Okay, we cannot query scale in workspace. So let's just get rid of the workspace flag. And we still get the warning, so I don't like the warning, so we're gonna just get the attribute. Oops. Oh, I can't type. There we go. Like that. So we see we have scale, we have rotation, position. So the scale is actually giving us a tuple inside the list. So let's get the first index, like that, and we have just a tuple. Perfect. So now what else we need? So the vertex count. Well, I believe there are several ways to do that. Like there are functions for query components and everything, but I'm a lazy guy, so we're going to do old school. So vertex number is going to be equal. So let's see. We can list the vertex and then get the length of the list. So we need the length of commands.list our mesh plus vertex. We need all the vertex and we need the flat tag. So basically it's going to create a flat list, otherwise it's merged together all the result and we're gonna just get one element. So let's see. Ooh, I forgot. There we go. So 8. So let's print actually m, so we know which print m. We know which object we are working with. So polygon cube 2, which one is this? This one, so it has only 8 vertices. Perfect. So we have the vertex number. Then the last things I want to get is the parent. Let's call it par. So here we go, the parent, and then I want the children, sorry. Command of list. I believe it's just like that. I'm not entirely sure, I don't remember. So let's see. So it's just giving me the shape. What happens if we filter for shape 0? Actually, I don't want the shape, but it's giving me the shape back anyway. Well, let's keep the shape, doesn't matter. Cool, so we have all the objects we need. So let's see the parent. So the parent, we just want one of just the single parent, so I don't want a list. So we're going to say if parent equal to parent 0 for the first index. So let's see. There we go, locator 2. Perfect. So now we have all the data we need. So we're going to build a dictionary with all this data. So let's call it current dictionary is going to be equal to all our data like that. So we have position is going to be equal to false. Let this comma. Then we have rotation going to be equal to rot. Oops. Then scale is going to be equal to scale again. Then we have vertex number. It's going to be equal to vertex number. What we have still, we have parents. Parent. So last children and is equal to children. Okay, so I think we added everything. Okay, so this is a way, this one, on which we can create a dictionary and add some keys to that. Okay, so we say to this key, example pose, correspond this value. In our case, this is the variable for the position, and then we do the same for all the other keys. There are other ways to add that. So for example, we could declare the dictionary empty like that. Oops, like that. Then we could just add the keys. Oops, like if it was a list. Then for example, position that equal to false. Then there are other specific methods for the dictionary that you can use for, but usually I only use those two. But if you want more information, just check the Python documentation. Okay, so now we have this data and we're going to store that in the main mesh data. So we're going to create a key, so mesh data, and the key is going to be the name of our mesh. So it's going to be mesh, and then we put it equal to our current dictionary. So simple enough. Let's run it. There we go. So now at the end we can print mesh data. Okay, and we can see we have all here a bunch of data. So we have as a main key we have the name of our geometry, and this key is holding actually another dictionary which has all a bunch of data. Like here we have the scale, here we have the parent, here we have the position, and we have vertex number, rotation, and blah blah blah. Okay, so that was the heavy part, so pretty simple. So now what we're going to do is store it on the disk. So in order to do that, it's pretty simple. We need a path, so I just create a variable with path. So for now I'm just gonna store it in my C drive. Okay, so you actually have to build your path. For example, if you are exporting all a lot of data in different files, you need to combine the string. In this case, it's just an example, so I'm going to store it on my C drive as a test scene underscore dot mesh data. Okay, so you can give any kind of format you want. So now what we need to do, we need to create a JSON item and dump inside our data. So let's create a variable called to be saved, and it's going to be equal to json.dump. Okay, so the dump is the method to serialize into JSON format our stuff. So what does serialize mean? Serialize means in a way transform your data in a way that is readable to JSON, so it can save it to disk. It knows how to handle that. So you can use all the standard values like string, float, and whatever. But for example, if you want to serialize a class with Python, with JSON has no idea what is that. you have to do that manually. That means you need to gather all the data and convert manually this data in a way that JSON is able to serialize it. Okay, so in this case we only have standard data like I said before, list with floats, integer, string. So JSON knows how to serialize that. But for example, if in the dictionary we're going to put a custom class, as I said before, we need to handle the serialization manually and give some data that JSON can actually put on the disk. Okay, so if you're not doing anything advanced, just don't worry about it. And of course, again, if you need more information about serialization, Google is your best friend. Okay, so now we need to provide as a first argument the data we want to store. So in this case, mesh data. Then we can specify a couple of options to get a better text file. So for example, sort keys. We're going to set it to true. Then ensure as key equals to true, and indentation equal to 2. Okay, so now that we have that, we need to open the file. So file is going to be equal to open our path in write mode. Okay, so now we call file.write to be saved, and then f.close. We close the file, and it's done, guys. That's it. So let's actually run that. Error. Oops. Dumps. My bad. It doesn't let me write on the C drive. So okay. Thank you for not letting me drive on the C drive. We'll just create folder here, tmp, then I should be able to write here tmp. There we go. So now we wrote our file. So let's go grab it, tmp. There we go. That's our file. We can open it, and we can see here we have all our data stored. Okay. So that was simple enough. So now we're going to do the opposite way, okay? So now that we have the data here, we want to read it. So in order to read the file, we need first open. So we're going to do f equal to open, and we need the path to our file we have already here. We can use the same variable again. And then mesh, let's change the variable name. So data file is equal to json.load our file. So let's do that. Now let's try to print our data file. Print data file. And we got back our dictionary exactly the same way we stored it. That's why JSON is so cool, because we don't have to waste time anymore splitting, concatenating, removing spaces in order to read the file, which was way painful. And also, JSON is really fast. It's faster than XML and other stuff. So I highly encourage you to use it. And also, you can use cpickle, which is a bit slower actually from the benchmark at least I saw on the internet, but it gives you way more power. You can write custom serializer and everything, so it's way more powerful than JSON. But for regular stuff like the one I'm doing right now, export simple data like that, JSON is more than fine. So now that we have the data file, we can actually print or get data we want. So for example, I want let's see, data file, I want the position of the sphere 4. Okay, so the first argument, remember, is our object, and then we have the dictionary available, so I want the position. So if I print, here we go, that's our position. Or what I can do, if I don't know the name of the object, which most likely the case, what I can do is for key in data file, so for keys in data file, so k is going to be my object. I'm going to print data file k position. There we go. So we have all the position in the dictionary, or all the rotation, or all the parents. So it was just par. Here we go. Okay. So guys, so this is the end of tutorial. So it was a quick introduction about the power of dictionaries and how easy it is to save and export stuff. This actually is really important, trust me guys, because so often, also when you have different software in the pipeline, exporting data from one software to the other, it's pretty common things to do. Okay, so I hope that was clear enough. I'm going to provide you this sample script, sample scene, and everything, so you can play and mess with it. Okay, bye bye guys.